Right, year 10. So today we're going to do more about the equations behind it. Before we were doing understanding, we were doing the left-hand rule, which is kind of hard if you're not in a classroom where I can teach you it. But today we're going to do the equation, which I think, from remote learning standpoint, is actually easier to do. You'll need a calculator, so you can use the one on your computer, but if you've got a scientific one, that'd be much better. Now, here's your equation. F equals BIl. You'll be given this equation on your equation sheet, so you don't have to remember it, but you do have to remember what each part means. So, F is the force, measured in newtons. We should know that one. We should also know I is the current in amps. Now, L is the length of the wire that is inside the magnetic field in meters. Okay, that's an important part. If there is a length of wire that is outside of the magnetic field, you ignore it. And B is the magnetic flux density. Okay, and that is in Teslas. So what I'm going to do this lesson, I'm going to give you an example. I'm going to work through it. I'm going to give you a few different tasks to do. At the next lesson, I'm going to mark them. I'm going to show you how to do them. So we're going to work through them together, even though we're not together. So here's our example. 2 amps flows through a 50 centimeter wire. Calculate the force acting on the wire when it's placed at right angles in a 0.4 Tesla magnetic field. That's important, that right angles bit, because this equation only works if the wire is at a right angle to the magnetic field. So let's leave this and pop over here. Now, 2 amps flows through a 50 centimeter wire. Calculate the force acting it. Well, I need F equals BIl. F equals B, I, and lowercase l. That's my equation. Let's arrange everything. So I'm going to, down here, I'm going to write down F equals B equals I equals. Now, I know this is tedious, but you should do this every single time because it helps a lot. It helps you spot when the units need to be converted, and it helps you spot what's missing. Well, current here. This, we should know, that is our current. 2 amps. 2 amps flows through a 50 centimeter wire. Now we know centimeter is a measure of length, so I'm going to write that here. Calculate the force. They've told me that I am calculating the force, so I'm going to box that. That is my question mark. So calculate the force acting on the wire when it's placed at right angles in a 0.4 Tesla magnetic field. 0.4 Teslas. Now, let me just quickly change to a green colour for a second. Well, we're working out that, so that doesn't matter. This is the correct unit. This is the correct unit. This is not the correct unit. We like to work in meters. So let us go back over. How do I get from centimeters to meters? Well, let's do our working out. Let's do our little conversion. Some of you will know the conversion in your head and be able to work it out just straight away. But you should always do this if you're not sure. I want it to be 1 meter. There's 1 meter. How many centimeters are in 1 meter? Well, I know that there are 100 centimeters in 1 meter. These two are equivalent. They mean the same thing. 100 centimeters is 1 meter. I've got 50 centimeters. I would like, let's change it to be a little bit pink. I would like my centimeter to change into a meter. How do I get from this number to that number? Well, I have to do this, don't I? Divide by 100. And there we have it. To get my length to convert, get rid of some of this. That's not what I wanted. Okay. Yeah, I have to divide it by 100, and we should know that that will equal 0.5 meters. Now, this is the correct unit. So let's go back to BIl. F equals BIl. Well, I'm calculating F Luckily for this example, there's no rearranging. Nice and easy. B. What's B? Well, it's 0.4. I'm going to leave the units out now because I know they're all correct. Times by I. What's my I? Well, it's 2 amps. Times by L, which I know is half a meter. I'm going to go to my calculator. Okay, because even though it's a simple calculation, I am not going to mess it up. 0.4 times 2 times 0.5 equals 0.4. So F equals 0.4 newtons. That's my answer. Now, I'm going to tell you what to do for your task. Then I'm going to come back here onto this board and I'm going to do some examples on how to rearrange equations. So if you don't need those examples on rearranging equations, you're fine. You can just crack on. If not, then you can come back. Right, here we go. We have got a bronze, a silver, and a gold. The bronze one is very straightforward. Okay. The mark schemes are on the end, so if you get stuck, you can look. The bronze one, I really don't want many people to do the bronze one. Okay. This is just testing knowledge from previous. Testing knowledge from previous lessons, checking you know how to calculate efficiency, and applying it to a practical. The silver one is where we've got a BIl question. You've got to describe Fleming's left-hand rule. Go back to last lesson. Make sure, okay, you say what the finger means and which direction it has to point. Then you've got an actual calculation down here. So for this calculation, you will need to put that number into a calculator. So you can either take it out of standard form and write it as a normal number, or you will need to use a calculator. If you've got your own calculator, that's perfect. If not, Windows has one. You click here, click scientific. This number there is 4 EXP. That's times 10 to. Because it's a minus, I've got to toggle the sign. Minus 4 equals. So there you go, it writes it for you like that. So you can use that to type it in. Now, that should be nice enough. And then the gold task is a bit more difficult. Okay. Again, you have to, using the F equals BIl, you have to try and figure out a relationship. Write the equation down. Ignore the variables that they don't talk about, so you're looking at current and magnetic force only, and then think about what would that graph look like. It's quite a good skill to have. Now this one is a more difficult BIl question, so have a really good go at that. If you get stuck, again, mark schemes are below. Now I'm going to go back to here, and I'm going to do a quick rearranging equation. Now let's do F equals BIl. What if you wanted I equals, so let's say our end product we need over here, we need I equals something. Well, the problem is I've got a B and an L near where my I is, so I don't want that, do I? Let's go to this colour. How am I going to get rid of B first? Let's get rid of B. Well, if I want to get rid of this B, I'm going to have to divide this side by B. But because this is an equal sign, I have to do the same thing to this side. Now the reason why I do this, if you look here on this side, this B and this B will cancel out. And I will be left with the next line, which is F divided by B equals I times L. Now, that's better. But I still want the I by itself. So this L needs to go here. So, again, I will divide both sides by L. If I was to put this in brackets, I can divide the whole thing by L, or I can write it as 1 over L here. Timesing by 1 divided by L is the same thing as dividing by L. But we'll not do that now. Just don't want to confuse. So I'm going to divide this whole thing by L. Now, this side's simple enough. You know that this L and this L will cancel out. They're gone. What happens here? That should be an L. I don't know why that's not an L. I'm going to rewrite it. F B, but I'm having all of this divided by my L, right? And on the right hand side, everything's fine, it equals I. If you are dividing, you put it on the bottom of the fraction. So this actually equals F equals B times by L, and that equals I. So my answer, we'll rewrite it here. I've just flipped the sides this time, equals F divided by B times L. So if you were going to work out I, and I wrote it like a fraction, if I was to write it not like a fraction, you do F divided by, open your brackets, B times by L. So you would work out B times by L first, then F divided by that answer. So hopefully that might help with a bit of rearranging. The algebra side is comes naturally to me. I think that putting numbers in makes it easier, but next lesson when we do the examples and we work through them, I'll put the numbers in. Then I'll show you how to rearrange like that.